Part 6, Fire Door Inspection Systems. 103. Fire door inspections. Fire door inspections, just like their design and specification, should be influenced by a number of factors including their age, usage and criticality, combined with the size, function and fire and evacuation strategy of the building in which they are installed. 104. Inspection types. There are 3 generic types of inspection that are proposed. Type 1, inspections, for newly installed fire doors. This is a prescriptive one, including invasive elements. Type 2, this type of inspection is to comply with the regulatory reform, Fire Safety, Order 2005, assessing if the condition of each fire door is suitable and sufficient in terms of meeting and maintaining the requirements of both the building's fire risk assessment and its fire evacuation strategy to protect relevant people and ensure safe evacuation or protection in the event of a fire. This inspection is potentially pragmatic and flexible, carried out on existing fire doors in occupied buildings where there is no evidence of performance and where no, or little, fire door information exists. Type 3, to manage and maintain compliant fire-resisting doors to a satisfactory standard. Undertaken on fire doors that have already been Type 1 or Type 2 inspected, where the doors are known to meet, have met the standard of fire compliance required and where a paper trail exists. 105. Type 1 inspections, for newly installed fire doors. New fire doors, especially in critical buildings, need to be installed correctly. Installation competency needs to be established, and this call for fire doors being installed and inspected under 3 less than SUP-RD/SUP Party Certification Scheme. If the door manufacturers and installers are not part of a third-party certification scheme, then an external handover inspection program must be carried out by those with the competence to do so. 106. Checking newly installed doors. Newly installed fire doors should be checked to ensure they have been fitted in conjunction with test evidence, the manufacturer's installation instructions or other evidence of performance. Installations of fire doors should be in line with manufacturer's installation instructions and, as with any fire safety item, should only be carried out by those with proven competence to do so. This is a legal requirement under Regulation 7 of the Building Regulations. A poorly installed fire door set is likely to render the manufacturer's certification invalid. More importantly, it can create life safety risk and will normally, eventually, lead to higher maintenance costs and the failure of doors, long before their expected life. 107. Death trap doors. The following articles and pictures illustrates the challenge of poorly installed fire doors. 108. Gaps and inappropriate storage. Door should be stored upright. Doors stored on their side can result in twisting and misalignment into the frame. 109. Door lock protected by incomplete intumescent. Excessive threshold gap. 110. Single self-closer on self-closing doors. 111. Manufacturer's louver grill not fitted. There should be a suitable intumescent insert within the body of the leaf. Where a smoke seal is required, it should be provided with an automatic closing device. 112. Single self-closer and single vision panel. 113. Back-to-back doors. 114. Frame back exposed and shadow gaps. Door leaves must not be proud of each other or from the door frame by more than 2 mm. 115. Avoidable costs. It should be understood that these are not just installation failures but failures of the whole system, also involving specification, procurement and handover procedures. From Property Services Agency, research in 1980, where doors and their hardware represented less than 1% of the total building cost, then those doors and their hardware would represent up to 80% of the building's maintenance costs. 116. Establishing competence. The Building Safety Act identifies competent persons as those with suitable skills, knowledge, experience and behaviors. Fire door inspection competence needs to be appropriate to the life safety risk, and relevant third-party accreditation, such as LPS 1197, is strongly recommended, together with professional indemnity insurance cover. Typically, those involved in specifying, installing and procuring fire doors should possess a background in fire door testing, manufacturing or installation with a thorough understanding of the fire safety order, building regulations, British standards, approved codes of practices and managing risk in premises. 117. Scope of a Type 1 inspection. The Type 1 inspection should extend to check suspended ceilings above the door, and for cavities under raised floors. This is to check compartmentation integrity and that the vertical fire line has been sealed to provide the required fire performance required. Type 1 inspection requirements for evidence of correct install at hold points should be contractually agreed between stakeholders in writing before installation takes place. 118. Evidential tools and software. Any inspection should use appropriate tools and be recorded. If the door installer is not in a third-party scheme installer, then essential installation information and competence standards should be evidenced, and a post-install handover Type 1 inspection completed. 119. Comparing what's installed with what's specified. Pre-install audit checks should be completed on doors, materials and door furniture. This should include physical checks on representative samples of components making up the fire door sets to ensure as designed is as specified and is as installed. Any variations constituting non-conformities should be recorded and assessed. Major risks identified, A, or minor as I, with any observation notes, O, provided. 120. Unique identification details for each door. Door designs and specification, along with installation information including evidence of installer competency, should constitute the building's golden thread of information. The golden thread of information required to manage and maintain the door throughout its life. Information captured should include name of manufacturer, information provided, fire door set test, assessment, installation details, fire rating and any other performance characteristics relevant to location, intended smoke seal requirement relevant to location, labeling or other method of identification by a 3 less than SUP/SUP party accredited manufacturer, providing information and traceability. Additional labeling or marking to identify installer including individual competency information. Any other identification or specification information. Golden thread fire risk assessor, fire safety engineer sign-off and approvals. 121. Door frames. Door frame checks and records should include width and thickness of frame members, free from knots, shakes, ensuring straight-grained and with an apparent low moisture content. Product and system specifications and what material it is made from. Door stop thickness and width. That it has been correctly installed to align with door leaf. That the frame and stop are both securely fixed, with no visual damage, cracking or twisting. The spacing diameter, penetration and material type of frame fixings into the wall including distance to wall edge, fixed within the fire compartment line with no frame back exposure. The gap between frame and wall, removing architrave if applicable, to ensure the seal is as per the manufacturer's instructions, GFRA approved or BS 8214/2016 compliant if bespoke details not known. That non-combustible packing hasn't been used and, or has been correctly fire sealed. That architraves have been installed, if required. Some specialist door furniture will require additional checks. For example, anti-barricade doors in a mental health environment. There is need to check that the anti-barricade device is engaged to ensure that the door is only single action in its normal state. 122. Door leaf. Door leaf checks and records should include middle dot thickness, width and height, leaf 1. Middle dot thickness, width and height, leaf 2 if applicable. Middle dot composition of leaf including skin and core material, that it matches the GFRA. Middle dot evidence of leaf cracking, core fractures, or other damage that may have occurred during transit or installation. Middle dot lipping thickness. Middle dot evidence of leaf cracking or other damage. The leaf should not be twisted and misaligned into the frame, and matching leaf if applicable. Push plates, kick plates and other surface coverings should be as specified. They may be factory-fitted or retrofitted, the latter requiring checks to ensure compatibility and in accord with design specifications. There should be a general fire risk assessor handover approval process. 123. Gaps and seals. Gaps should be inspected to check that they are uniform and between 2 to 4 mm at the top, hanging, closing, meeting and at the bottom. Smoke seal should be checked for defects and damage, condition, and correct fitting and functionality. The type, manufacturer and specification should be recorded. They should be of the same material along top and vertical edges. The maximum threshold gap for smoke seals on smoke control doors, which should be identified with suffix S or E, should be 3 mm. To reduce ligature risks in mental health environments, the intumescent/cold smoke seals may be fixed in a series of shorter lengths. Checks will be required to ensure that they are all securely fixed. 124. Hinges. Hinge checks and records should include number of, position of all hinges, make and type, ball bearing, bush bearing, lift off, etc. Size, BSN 1935 grade and CE, UKCA, marking. Intumescent hinge protection if required, that there is no other packing. Hinges holding the door secure and upright. Correct number, type and size of screws. All hinge blade fixing holes have manufacturer-supplied screws in place. It is of note that anti-ligature hinges may be full length and double action. There should not be more than a 3 mm gap above the hinge. 125. Closers. Closer checks and records should include type, manufacturer, product reference, CE, UKCA, marking, BSEN 1154 or BSEN 1155 approved for door rating. Set to correct power size. The device has been installed in accordance with the manufacturer's instructions, including suppled fixings are all in place, correct location, arm geometry, and the arm anchor clevis is securely installed directly to the frame head member. No evidence of oil leakage. From maximum possible opening angle and 75 mm, function to ensure that the latch bolt engages fully into the frame strike plate from both positions. Opening force, for Part M compliance if required. Closing speed. Details of hold open device, including door wedge, if applicable. Will the door close automatically in the event of a fire or power failure? It is of note that door closers in a mental health environment are often fitted into the transom head of the door frame and integrate with the double action hinge. There is a need to check for both fire test compatibility, compliance with the manufacturer's global certification of conformity, and that it is anti-ligature. 126. Locks, latches, handles and bolts. Locks, latches, handles and bolt checks and records should include manufacturer, product reference and CE, UKCA, marking, BS 47622 or BSN 1634.1 compliant, tested to door rating. Intumescent protection around casing, under lock forend or frame strike plate as required by the specification. Self-latching function of latch bolt, if applicable. Dead locking action of dead bolt if applicable. Functionality of handle. Height of handle, i.e. approximately 1 meter from floor, Part M compliance. Functionality of bolts if applicable. Intumescing protection is installed to any integral bolts, for example flush bolts, in accordance with the GFRA. 127. Other ironmongery and additions. Other ironmongery that requires checks and recording of suitability and correct installation includes latches, handles and bolts. Information to be recorded includes information relevant to door coordinators and function. Door coordinators ensure the synchronized operation of double doors, allowing for swift and secure closure during a fire event. The coordinator acts as the essential link between the door closers, ensuring both doors close simultaneously and maintain the integrity of the fire-resistant barrier. Additionally, one of the main functions of the coordinator is to eliminate the risk of door misalignment. Without a coordinator, the door closers on double doors may not align properly, leading to uneven closure or gaps between the doors. Consequently, these gaps can allow flames and smoke to pass through the door, negating its purpose. Letterbox. Dimensions. If the aperture was cut by the door manufacturer or someone else. The make and product reference. Door manufacturer evidence of fire test and compatibility. Evidence of intumescent and its performance specification. Air transfer ventilation grill. Dimensions. Specification. If the aperture was cut by the door manufacturer or someone else. Type of closing device, heat activated. Electromechanical. And if suitable, compliant, for location. Make and product reference information. Manufacturer's louver grill fitted. Door signage. Checks should be undertaken to ensure all fire door signage complies with requirements set out within BS 5499-10, 2014. 128. Vision panels. For vision panels, if applicable, inspection records should include any impact damage, glass pane fractures, glass pane delamination. RBS 476-22 or N1634 to 1 mark visible. If the aperture was cut by the fire door manufacturer or someone else. Width and height. Check the width and height are within the manufacturer's fire certification dimensions. Type and make of glass, identity marks. Insulated or integrity only. Part M compliant. Glazing detail, beading firmly fixed, intumescent gasket specifications, detail. In a mental health environment there is also a need to inspect the glazed elements, especially if they have openable viewing glazing to ensure they have appropriate fire resistance in addition to any security requirements. 129. Condition and suitability of supporting wall. At design or tender stage of projects there is certification of fire door sets to support their unique building project installation details. This takes into account the installation of fire doors in fire-rated plasterboard walls. Very few fire door manufacturers have their doors tested and certificated for incorporation into drywall construction. A layperson assessment of the wall and door is not a fire test and certification as fit for purpose. 130. Automatic door releases and controls. Many new fire doors in premises are held open and controlled by automatic devices, and it is key that those responsible for the new door installation and the fire safety of the building will need to ensure that the system is both functional and compliant. Whilst manual self-closing operation is tested, the interfacing 6-monthly fire alarm system test should be completed under the LPS 1197 standard by a registered specialist door control company or the incumbent fire alarm service provider working to LPS standards. 131. Type 2 inspections. Type 2 inspections are required to assess the performance of existing fire-resisting doors where no or little information on the door currently exists. They need to be carried out by competent persons to a recognized standard with evidence of check, a pass, fail criteria. The results should be recorded electronically and form part of the building's golden thread of information. The level of inspection needs to be suitable and sufficient for the type and use of building and location, risk rating, of doors. For inspecting existing doors, the approach to inspection should be pragmatic and flexible. It is aspirational and neither practical nor affordable to require all fire doors currently in situ to achieve an as-tested standard, with a requirement to potentially replace a very large percentage of them. This is also not necessary, because fire doors only need to achieve a suitable and sufficient standard. 132. Expertly assessed and 3 less than SUP-RD/SUP party certified. Once performance has been expertly assessed, there can be 3 less than SUP-RD/SUP party certified, sometimes for the first time, under such schemes as BRE/LPCB LPS 1197. For relatively new doors with test and certification evidence for the fire door set as fire tested and for others missing information to the limitations of their repair to achieve a suitable and sufficient standard. All inspection evidence along with the competence of the assessor should door electronically recorded and form part of the building's golden thread. 133. ASFP view. The ASFP view on the prevention of smoke and fire within a building is that fire risk assessors will need to undertake an evaluation of PFP in a building. In practice, smoke is one of the major causes of deaths in fire, and consequently a competent risk assessor should concentrate on passive fire protection measures that restrict the spread of smoke within the building. Competent evaluation of fire doors should focus on measures to improve capability to restrict the spread of cold smoke. 134. Fire door performance in a real fire. Pragmatic assessments should also take into account that in a real fire situation, if other complementary passive and active fire safety measures have been installed to expected standards and undamaged, it is unlikely that many, if any, fire doors will be burnt to destruction. It is of note that whereas on one side of the doors to the room has been totally destroyed, the fire doors have held back the fire to the extent that on the other side of the wall there is a paper notice still hanging undamaged. 135. ASFP's view. The input of a fire safety engineer should be obtained to validate the fire doors and compartmentation standards are in line with the building's fire safety strategy. With regard to the required integrity of the door, the ASFP's view is that regulatory guidance recommends doors which satisfy integrity for 20, 30, 60 or 90 minutes. These times are a good basis for new build, but are not carved in stone. A risk assessor may consider that for some buildings existing doors of a lower period of fire resistance are satisfactory, or conversely that doors of a higher performance may be needed to contain the risk. The objective of a fire risk assessment is not to ensure slavish compliance with regulatory guidance but to maintain tenable conditions for the occupants. 136. Typical issues encountered in a Type 2 inspection. The following are examples of typical issues encountered in a Type 2 inspection. Lack of a tested and certificated fire rating. Check for door thickness, label. As a guide, a 30-minute fire door will often be 44 to 45 mm thick and a 60-minute fire door 54 to 55 mm thick, but this is not always the case. 137. Door leaf issues. Reasons for door leaf non-compliance include: excessive structural damage or distortion is evident to the door/frame/lippings. Damage to the leaf except for plugs not exceeding 25 mm, see below. Any evident alterations not in accordance with original certified installation. Asbestos discovered as part of the door construction. It will normally be understood that a door containing asbestos should not be remediated due to safety and cost factors. Door leaf is too small, i.e. door leaf to frame gap is too large, to allow sufficient adjustment. Existing repairs not carried out to a recognized standard. Cost of repair is more than 70% of cost of new replacement. This percentage is given only as a guide and will vary and be dependent on client input. 138. The condition and suitability of door protection. The condition and suitability of door protection should be examined. It's of note that issues might be immediately hidden from view. 139. Reasons to replace door frames. Following a fail assessment, there may be need to replace the door frames and potentially the whole door assembly. This may arise from integrity of the frame, excessive structural damage, and when distortion is evident. The fire door frame may not provide the rating required due to concern over its constructional materials. Softwood or other material may not be able to provide, for example, a 60-minute fire rating. 140. Door alignment. Door leaf should be closely aligned to the frame or leaf to leaf in double doors. New door sets are expected to meet these standards. Typically, fire tests will require that leaves must not be proud of each other or the door frame by more than 3 mm, otherwise the door's fire integrity could be seriously compromised. If misalignment is caused by leaf warp, then there's not a lot that can be done, but it is often due to the frame having not been fitted square, and this can be adjusted. 141. Restricting the spread of smoke using smoke seals. Intumescent strips can cause confusion. It is of note that an old door may not have the seals that you would expect to find on a new door, and a view will have to be taken as to their suitability. If a smoke seal is not in full contact with the door edge and frame and daylight is visible in between, then the seal is not effective for restricting the passage of smoke, and this must be addressed. Where damage is evident to the existing door strip, then the complete strip on all sides must be replaced. Whenever possible, the replacements must be the same as the replaced strips to maintain the door as near to its certificated construction as possible. Different makes of intumescent strip must not be mixed and matched, as they will potentially activate at different temperatures. 142. Painted seals. If a cold smoke brush or fin has been painted, then these must be replaced as their capability will be compromised. However, an intumescent seal without a cold smoke appendage can be painted over. if unavoidable, with up to 5 conventional coats of paint or lacquer, or 0.5 mm thickness, whichever is greater. 143. Excessive threshold gaps. Excessive threshold gaps should be recorded and remediated. Smoke-sealed doors require bottom edge, threshold, gaps not to exceed 3 mm in existing buildings, and dependent on risk factors, a pragmatic view can be considered. 144. Appropriate threshold gaps. Risk factors of dependency of residents, patients, asset values, mission-critical assets, risk factors and room size and fire growth rate, FGR, should be considered. The risk factors can be used as an aid in deciding whether the threshold gap of existing fire and smoke control door in healthcare or premises with high-value assets, mission-critical assets and high-risk factors behind fire doors is acceptable. For amber zones, up to a 3 mm gap is acceptable. For green, lower risk zones, up to 10 mm gap is acceptable. 145. Hidden gaps. Any unsealed or incorrectly sealed gaps between rear of frame and wall may considerably reduce the fire resistance of the compartmentation and should be filled to the manufacturer's fire test detail where available, with evidence of performance including correct depth to width ratio, which for intumescent sealants tends to be 1:1. The use of polyurethane foam without unambiguous test evidence should be treated with suspicion. In the absence of manufacturer's information, it is recommended to follow guidance given in BS 8214/2016. 146. Gaps hidden by architrave. Gaps will often be hidden by architrave, and a decision will need to be made whether to investigate the gap for compliance. There are 3 suggested options. There is confidence and reputable evidence of the gap being correctly sealed, no action is required. There is no evidence or confidence of compliant gaps, so 10% of architraves are removed for inspection, which will be extended if a number are found non-compliant. Where the location is assessed as being low risk and there is no evidence or confidence in there being gaps, and the potential non-compliance is not thought to be significant, invasive inspections behind architrave are not called for. 147. Obvious glazing defects. It may not be possible to definitively establish a fire rating on existing glazed doors without a paper trail, but there may be some obvious defects to assess. 148. Glazing issues. All single sheets of fire-rated glass give an integrity-only rating, and extra care should be taken when assessing glazing in areas where temperature and/or acoustic insulation is required, particularly refuge areas. In such locations there may be a need to fit an intumescent laminate glazing system to provide the required rating. In care units, vision panels can sometimes be changed for reasons such as privacy or impact resistance, and there may be a need to check for both fire test compatibility and the manufacturer's global certification of conformity. Security glass tested to BS 6206 or similar with no relevant fire testing will not provide fire integrity. 149. Glazing issues continued. Glazing in older fire doors will often be Georgian wire, and although some can provide up to 60 minutes integrity, it should not be assumed that they have any fire rating without evidence of performance. A pragmatic view of providing up to 30 minutes integrity may be allowed short-term for low-risk locations if the glazing system appears to be factory-fitted, is free from damage, tight in the frame, and does not have any of the glazing bead missing or damaged, but it should be recorded as a potential weak spot. Any obvious signs of non-conformance such as ad hoc mastic around glazing should not be tolerated and necessitates replacement. Newer doors should have glazing tested to give a 30 or 60-minute rating and should clearly display the CE, UKCA, mark in one corner and carry details of the manufacturer and fire rating. 150. Door closers. For door closers and to identify and remediate closing issues, the following visual checks should be undertaken. Is there a CE, UKCA, mark or model reference? Check for suitability. Is the closer correctly attached to the door leaf and frame? Check for any damage and leaking oil. Is there any obvious damage to the pivot arm and terminal fixings? Does the door close fully into the frame? If a double-leaf double-acting door, does it close in the fully aligned position? If rebated double-leaf dorsets are fitted, check for the presence of a suitable coordination device. Check that any such device functions correctly to ensure that the leaves close in the correct sequence. 151. Hold open devices. Where a compartment, subcompartment or room has heat detection only, electromagnetic hold open devices, electromagnetic self-closing devices and battery-powered devices should not be fitted to its fire doors if they are suffixed with ans or e and the doors provide a means of escape or protect a means of escape. Electromagnetic devices designed and manufactured with integral smoke detection are permitted. 152. Checking the opening force for Part M compliance. Open the door wide and check, full action, the door's opening force, i.e. if it complies with Part M accessibility, commonly known as DDA compliance of less than 30 newtons, N, pressure between 0 and 30 degrees and below 22.5 N between 30 and 60 degrees may be a consideration, especially on doors that do not have a hold open device. Use a calibrated Persola gauge or similar. Open the door 5% or 75 mm and check that it closes and engages the latch if present. 153. Doors with 2 hinges. It is normal to expect a minimum of 3 hinges on a fire door, not only because that is how it is likely to have been tested, but for practical reasons, because of the weight of the door needing a middle hinge to support the top hinge and to prevent it from deflecting when exposed to high temperatures, but it is not uncommon to find only 2, in which case it will have to be assessed whether it is allowable as is, whether the door leaf or door set should be completely replaced, or if it is possible to fit 3 new hinges. The absence of a 3 less than sup/RD/sup hinge on a 60-minute door is unlikely but should not be tolerated. If a door has a door hold open device attached to it, then it must have 3 hinges and the third hinge needs to be in a position that supports the door to prevent warping. 154. Visual checks. Visual checks of hinges should include checks. For hinge grade, modern fire-rated hinges are tested to BSN 1935 and minimum requirements are grade 11 for a 30-minute door with a maximum weight of 80 kg and grade 13 for a 60-minute door weighing 120 kg. They should also be CE, UKCA, marked, applicable to fire-rated hinges, door closers and some locking devices post-June 2013. On older doors the equivalents are BS 7352 Class 8 for a 30-minute door and Class 9 for 60 minutes. To ensure that the hinges bear the weight of the door leaf in the frame and allow the door leaf to swing freely. To establish there should be no missing screws or wear, carbon deposits, metal fragments, on hinge knuckles and pivot pins. To ensure that no part of the hinge extends across the thickness of a 44 mm door closer more than 12 mm from the non-pivoting face and 18 mm for a 54 mm door to inhibit heat transfer. If applicable, there should be checks to ensure they are anti-ligature and in compliance with HPN 03-01. 155. Hinge considerations. A common hinge configuration on fire doors, to support the weight and replicate a manufacturer's fire-tested detail, is 2 near the top and 1 near the bottom, but 3 equidistant may also be as tested and is acceptable when the door is not overly large or heavy and is not showing signs of dropping due to excess weight being applied to the top hinge. Relatively new 60-minute timber doors are likely to need intumescent protection behind the hinge for the door to achieve a satisfactory fire test, but this will not always be the case and is unlikely to occur on doors in excess of 20 years old complete with original hinges. Fitting intumescent pads behind the hinge is a good way to equalize the gaps between the door leaf and frame, and fitting them behind new hinges on an existing door is seen as good practice, but there is no legal requirement for them to be retrofitted on doors not tested with them. 156. Pivot systems. On unlatched double swing doors, normally created by a floor spring pivot system, there is the need to ensure that the vertical edges do not taper and create uneven gaps, or have become misaligned, often an indication of excessive pivot wear or movement, which in the extreme will lead to leaf drop, increasing the likelihood of doors not self-closing. Double swing action via transom concealed closer and pivot assembly, often used where reduced ligature points are required or for a retrospective installation, have similar traits and should be similarly inspected. For both generic types there is also the need to check that the pivot assemblies and transom closer housing have a 2 mm thick intumescing liner installed throughout the top and bottom pivot recess, which is likely to have been required for the doors to pass their fire integrity test. 157. Issues with locks. Common issues are retrofitting digilocks which may not be fire-rated, replacing an old lock without repairing the door leaf and locks not latching. Bolts for locks or latches should be regularly checked to ensure that they fit centrally into their respective keeps and hold the fire door leaf into the frame. Lock levers should fully return to the horizontal after use. 158. Air grill, transfer louver, issues. Attempt to confirm the presence of a suitable intumescent insert within the body of the leaf. Where a smoke seal is required, check for the presence of an automatic closing device. 159. Signage, inspections should check that wording is logical for door use. The sign is in a prominent place and easy to read. It is in good condition. Note signage does not have to be put on the inside of a cupboards. 161. Type 2 inspection case studies. As an example, of 21 doors inspected in a large London hospital, fire door assessors were tasked with reviewing the required fire safety ratings of compartment lines in accordance with the building's fire strategy plans and Fire Code HTM 502. The inspection results were as follows: 10 major fails, 11 minor fails, 0 passes. 162. Door 2 cross-street door, risk manage and remediate rather than replace. Applying prescriptive inspection methods in line with Fire Code 05202, the door and other sister doors would fail with no potential to remediate. It was determined that the street, corridor in a hospital, discharging people onto the stairway had a low fire load and growth rate. Using a low-risk rationale, new doors would have low benefit with high cost. A decision was taken to adopt a pragmatic approach to fire compartmentation based on risk v benefit accounting for cost. It was decided to remediate the existing door assemblies rather than replace the full door sets. 163. Door 5, electrical plant room door, no potential to remediate. A doorway discharges directly onto this vertical escape stair at ground level, so may have an impact on available safe egress time, ASET. The door was described as a high-priority item and required to meet the minimum standards laid out in Fire Code HTM 502. This assembly had no potential to meet minimum standards and a decision was taken to replace. 164. Door 13, storage cupboard door opening directly onto the stairway, removed from strategy drawings. The storage cupboard enclosure was never intended to be fire-resisting and contained low-risk items. A recommendation was made to amend the fire strategy and remove the store from drawings. Noting its sensitive location and the potential to compromise OSET, a decision was taken to limit storage to items with low fire load, non-combustible, and restrict access. The current lock, a plastic tie wrap strap, was replaced with one restricting access to known key holders. 165. Conclusions from the hospital inspection. Rather than remove and replace 11 doors under strict adherence to Fire Code, a risk-managed approach to reduce the number to 3 without compromising assessed life safety was taken. 166. Stakeholder consultation. Proactive engagement with stakeholders including the fire and rescue service and, where present, residents. There is need to ensure inspection procedures and intended level of fire compliance are agreed, met, and communicated. In large complex building, this has become a legal requirement. For higher risk buildings as defined under the Building Safety Act, 18 meters or 7-story containing 2 or more residences, replacement of a leaf in a fire door is a material change and will require application to the Building Safety Regulator for approval. Reference Building Regs 2010 and the definition of building work 3.1, and description of a material alteration 3.2. 2. An alteration is material for the purposes of these regulations if the work, or any part of it, would at any stage result a. in a building or controlled service or fitting not complying with a relevant requirement where previously it did, or b. in a building or controlled service or fitting which before the work commenced did not comply with a relevant requirement, being more unsatisfactory in relation to such a requirement. 3. In paragraph 2, relevant requirement means any of the following applicable requirements of Schedule I, namely: Part A, structure. Paragraph BL, means of waning and escape. Paragraph B3, internal fire spread, structure. Paragraph B4, external fire spread. Paragraph B5, access and facilities for the fire service. Part M, Access to and use of buildings. 167. Type 3 inspections. Intended to manage and maintain compliant fire-resisting doors to a satisfactory standard, meeting the requirements of Articles 17 and 38 of the FSO. A number of factors help determine a satisfactory standard, a suitable system, and the frequency of inspection, not least the usage and importance of the doors in terms of overall fire containment. 168. Practical tools, fire door inspection gauge. The fire door inspection gauge and similar checking devices are thought to be suitable for regular, practical follow-on inspections. You can use this 3 mm thickness to check door leaf-to-frame gaps. Use the mirror to check the top of the door. Use the card to check door alignment. Use the measure to establish the door thickness and the threshold gap. 169. BS 9999 to 2017 Routine Inspection and Maintenance. BS 9999 to 2017 provides specific guidance, and any ongoing inspection of doors that have previously been inspected and found to be fire compliant to an acceptable standard are likely to consist of inspections to this or a similar standard. It is not directly applicable to healthcare premises. 170. Fire door automatic release mechanisms. BS 9999 to 2017 gives the following guidance. All doors that are held open by automatic release mechanisms should be released daily. Automatic opening doors. The operation of fail-safe mechanisms should be tested once a month, either by breaking out the door set or by simulating failure of the mains power supply, as appropriate. The results of the test should be recorded. Any doors that are found to be faulty should be repaired or replaced. Doors on hold-open devices. The operation of hold-open devices should be tested once a month by simulating failure of the mains power supply or operation of the fire alarm system. The results of the test should be recorded. Any doors that are found to be faulty should be repaired or replaced. 171. Important factors. BS 9999 is a guidance document, not mandatory, and does not consider the criticality of the door in terms of location, frequency of use, likelihood of impact damage. These are all important factors which should be considered when determining inspection frequency of fire-resisting doors. 172. Criticality. How important the fire door is in the context of the type of building, the actual location of the fire door, and therefore the level of risk it protects needs to be considered by the building's fire risk assessor, taking into account the building's occupants, the evacuation strategy of the buildings, and any PEEPs in place. The size and design of the room being protected is also a factor. For example, low ceiling heights could greatly increase fire growth rate as could the room's fire load. In addition, there may be areas of a building that are critical in terms of maintaining business continuity, for example a comms room. Although not critical for life safety, the loss of such equipment and resources may be critical to the viability of the building and organization, and the appropriate level of required fire compliance should be recognized. 173. Frequency of use. Doors which are used frequently are more likely to be susceptible to damage or wear. There are 3 levels of usage in this example, however this may be varied where manufacturer's guidance is available or robustness of door is established. High, typically, cross-corridor doors, stairwell doors and other doors likely to be opened regularly, more than 100 times in 24 hours. Medium, typically kitchens and doors likely to be opened between 10 and 100 times per day, 24 hours. Low, typically service riser cupboard doors likely to be opened considerably less than 10 times per day. 174. Likelihood of impact damage. Doors which are frequently used for access by beds, trolleys, bins, cylinder carts, etc. are more likely to suffer damage. Doors identified with a high likelihood of impact damage should be inspected more frequently than those with a low likelihood of impact damage. 175. Criticality usage impact matrix. Factoring in these issues may lead to adopting the following matrix or similar. 1. Where there is low, daily, usage less than 10x in 24 hours for very high dependency inspections to take place every 12 months. 2. Where there is medium, daily, usage less than 10 to 100x in 24 hours for dependent and very high dependency people inspections to take place every 6 months. 3. Where there is high, daily, usage greater than 100x in 24 hours for very high dependency and dependent persons inspections to take place every 3 months. 4. Where there is high, daily, usage greater than 100x in 24 hours for independent persons inspections to take place every 6 months. 5. Other inspections to take place every 12 months. In terms of the application of a matrix in higher-risk residential buildings and those above 11 meters in height, the frequency of inspection is prescriptive and the matrix does not apply. 176. Practical considerations. A Type 3 inspection is to maintain functional use of a fire door that has already been inspected in terms of fire performance. As such, it may be appropriate to be carried out by estates personnel or fire wardens who are not experts in fire door compliance. It may be appropriate for an accredited inspector to perform spot checks, especially in high-risk locations, to audit the process and ensure fire compliance is maintained. Having inspections at different time intervals in the same part of the building can lead to confusion. This can be minimized by having a color-coded system so that doors with one color sticker are checked monthly, another color 3 monthly, and so on. The closing speeds on doors held back by automatic closing devices needs particular attention, as their release on alarm activation or loss of power can be a safety risk if there is a violent closing speed. 177. Practical considerations. For doors held back on devices, it should be noted that industry standards for closing speeds are flexible to allow for one that is suitable for the environment. Without any instructions being given, the closing speed for doors are typically set at 7 seconds. It is good practice to release held-back doors at night, not only to close fire compartments but also to release door leaf tension, which is liable to cause warping if they are permanently held at just the top or bottom of the leaf. Areas where there is a pressure differential system should be checked when the system is switched off to ensure the doors will be functional and compliant in an emergency situation. Those conducting Type 3 inspections should be proactive in ensuring that fire doors are not being routinely wedged open. 178. 50 ways to wedge a fire door open. 179. Beat this?